Hello and welcome. Today we're going to talk about 3 experiments to learn about the behavior of gases. Experiment 1 will be performed with a little colder recipient, cold and hot water, and a pair of utensils. But before we make the experiment, we need to understand Charles' law. Charles' law established that gases expand when heated and contract when cooled, meaning that we should see the can expand and contract. To perform this experiment, first, fill it with about an ounce of water. Then, heat up the can in a dish of water for about a moment, and you will see the fumes steaming from the kickoff of the soft drink can. Finally, using utensils, you can get the can and place it in the topsy-turvy in a bowl of cold water. It is very important that you do not touch the hot can, as it can hurt you. Now that you've done this, what do we see? The can is crushed rapidly. This is due to the vapor exiting rapidly, while the cold water assembles the smoke, making the weight of the can extremely low inside. This happens so quickly that the ordinary pneumatic pressure outside the can completely crushes it. If this happened to you, you have successfully applied Charles' law. In experiment number 2, we will need 2 candles, a beaker or a large glass, a shallow dish, a butane lighter, water, food coloring, goggles, gloves, or a lab coat. But first, we need to understand Gay-Lussac's law of ideal gases. According to the WTFE, it states that for a given mass and constant volume of an ideal gas, the pressure exerted on the sides of its container is directly proportional to its absolute temperature, which means if the temperature increases or decreases, so will the pressure. Now that we understand this, let's perform the experiment. First, fill our dish with an ounce of water. Then, we add a small amount of colorant, but enough to color all of the water. Next, place the candles in the center of the recipient and light them up. Finally, place a large glass on top of the candles. What do you observe? If you notice carefully, the candles will light off after some time, while the water level rises. But why? Because when the temperature increases, so does pressure. This pressure pushes the water upwards. For our final experiment of the behavior of gases, we will need to visit the website in the description of the video. Before you do, let's learn more about Boyle's law. As established in Britannica.com, it is a relation concerning the compression and expansion of a gas at a constant temperature. As said by the UCCS, in this experiment, you will examine the effect of pressure on the volume of a gas at a constant temperature and formulate the relationship between the two. The procedure can be found on their website or here in our video. Now that you're on the website, click anywhere on the apparatus to start the lab. But you must note that the piston itself has a mass of 1 kilogram. Click on the pressure gauge to see a close-up of the measuring devices. If you want, you can click on the stack of weights to move one into the piston. Now, record the valves in the next row of the worksheet that is provided to you on the website. Repeat steps 5 and 6 to record the pressure and the height of the piston with increasing number of weights. You may click either the stack of weights on the bench to move them up into the piston, or stack on the piston to return one into the bench. Now, what do you see? Did you get the results on the screen? What can we observe from this chart is that as weight increases, it increases the pressure of the gas, which compresses it more, increasing the pressure overall. And we are done. Thank you for your attention. Be careful when you perform each of the experiments, and have fun.